Yeah, I've got Dan here. I believe if I've got everything in the right order. Dan, yes, I have got Dan here. Great.
Yep.
Fantastic. Hi, Dan. How you doing?
Good. How are you?
Yeah, I'm good, thanks. Great. Yeah, if you want to share your screen, along the bottom, you'll see there's a series of icons. About the fifth one, I think, along. There's a picture of a screen there, and
Cool.
you can share your screen there.
Sounds good. And I had a few slides if it was helpful, just like to walk through those briefly, or I can just dive into the workshop. Either way, it works for me.
Well, I mean, if you want to do a few slides and just kind of give a bit of a kind of an intro and a background as well, I haven't sort of yet given any kind of introduction to the to this workshop or talk or even who you are. So
For sure.
feel free to give a bit of an introduction, to yourself and about Tableland for those that haven't come across Tableland yet.
Cool. Yeah, it sounds good. So let's just double check. Cool. Yeah, so I'm Dan from the Tableland team, part of the growth side of things. So focusing on developer relations and helping developers onboard to the protocol and build with Tableland. So what is Tableland? It's a decentralized cloud database built by and really powered by the SQLite engine. So what it allows you to do is build Web3 native applications using EVM chains for the actual like rights and permissions associated with all your data, but also leverage the Tableland database network to really facilitate things like queries and actually accessing that information in a way that makes it a lot easier for developers, especially if you've been trying to like fit things into like the Web3 mold and it just hasn't worked out very well. And that's really what like our vision for Tableland is to be like that decentralized relational database for Web3 applications. That could be like it's really a database is a pretty broad solution. So like what could you use Tableland for? So in in like this context, it could be like application data. It could be data directly from just smart contracts and blockchains. It could be data sets or data pipelines, information that you're just trying to sort of like pipe into tables and use tables to store that information, or could even, especially like relative to the FVM, really augment some of the file storage there, especially when you're thinking about the programmability with smart contracts. Now you can really like use Tableland in tandem with Filecoin to store large data sets, describe them with tables and like metadata, really like Tableland's focusing more on the smaller pieces of data, whereas like Filecoin focuses on those large pieces of data, or even storing things like deal data within Tableland tables. So all of that can really be powered by the smart contract and leverage Tableland across your entire application stack. And then I'll breeze through these, but just like context for how people store data in Web3. This is like really generalized. So it could be like on chain in smart contracts where you're storing data in mappings or structs or this and that. Not all data really belongs in smart contracts. There's challenges with it around like query features and expensive mutability. You could store information in decentralized file storage, which obviously is great, but there's also really especially before the FVM, there's some drawbacks with just storing data strictly in there because of just like some of the query features associated with like a CID, for example. Like how do you know what data is underlying that CID and the actual like, immutable nature of the, CIDs in general. Like that has some drawbacks, and that's really where like Tableline can help actually describe the underlying data within some sort of CID or file that you're storing on Filecoin, and then give you like native queries to that information. And then some developers in Web3 are still using centralized database solutions just because it's like challenging to store data in ways that like you want to be Web3 native and want to have this like open sort of permissionless way to store information. But until Tableland, we feel like that really hasn't been an option. And that's why people have turned to centralized database solutions. So then Tableland basically comes in, tries to like marry all of the best from these different approaches into one solution, which is this decentralized database built on top of and sort of adjacent to as well EVM chains. So with FEVM launching, that's obviously like something we're super excited about. And we're really just a couple, I think we're just about to launch on mainnet, but on Filecoin Hyperspace, good to go there. So that's what I'll be walking through here today. And then just like generally, when you think about Tableland, like, okay, what can you do with it? Like general flow, you have maybe some application layer, or maybe you're just directly interacting with smart contracts, but you have some sort of interaction that's triggering a call to a blockchain. So what this is really trying to say is that all the rights and permissions and table creates, all that goes through the blockchain first. It's written to event logs. The Tableland network has a smart contract on these EVM chains that really allows you to like write SQL on chain. Off chain, there's this Tableland network of nodes that are running and listening to those on chain events. So then at the application layer, you can actually read the data. So Tableland, in this like context, acts as sort of this middleware database to enable you to like scale your actual application in a Web3 native way. And then there's plenty of information on our docs site. That's docs.tableland.xyz. This is a quick snapshot, just walking through like some of the more technical specifics for how that flow works between like the Tableland registry and how SQL is emitted from smart contracts. But we can always dive in at a later point. And obviously, I'll be on Discord and whatnot. So if you're curious, you can always ask me some questions there. And then lastly, so what we'll be walking through today is like actually using Tableland within your project. So there's like two ways you can, like there's multiple ways you can use Tableland, but like two of the most common ones, you can write SQL on the front end or SQL on the blockchain. And on the left-hand side, won't necessarily be a front end in this workshop, but we'll be using the Tableland SDK to actually like write some data and read some data, which is pretty cool. But then we'll also be using SQL on the blockchain within our smart contracts for like creating tables and writing data. So you can have smart contract powered data being written to this decentralized database and all accessible via the SDK for even writes or creates, but also just for reading that data strictly. And last thing around use cases, again, pretty broad for really a database. Like you can store everything is a database, right? So it could be anything from like data DAOs or tooling. If you need identity controlled information, so if you want to only control certain rights to data sets or only control a specific cell based on rules that are programmed in a smart contract, that's like really a superpower of Tableland, because all access controls are dynamic and defined within a smart contract. Or it could be application data, it could be something collaboration oriented, or on like the other side of things, maybe it's NFTs or gaming, and just the ability to store that information and control that access accordingly. Cool. So I'll pause there and move into the workshop.
Cool. Yeah, this is it's yeah, interesting where you get that, you know, the mix between the immutability and mutability, right? It's easy to do one, it's easy to do the other, and then Tableland kind of comes in. It's like, okay, sometimes you need a bit of both, and here's how we can do it. So
yeah, exactly. And I think on that, like, and there's even ways, like if you want data to be immutable in Tableland, you could set up the rules that way. But we just view that a lot of information should not be immutable, and it like should have mutability. And so like we're really trying to like change that paradigm, which especially like coming from the NFT space, like certain projects, that's not like exactly my background, but we've dealt with a lot of NFT projects as well as like data and everything. But NFTs maybe have focused on immutability and never changing your PFP, but we think that should be totally different and much, no game really is ever immutable, right? As things
right.
that you're changing. Okay, cool. So let's kick this off, and we're just gonna first, I created a directory called FVM demo. So if you're following along, feel free to do that. And then we're just gonna actually just set up a hard hat project, and we'll just go through the basics. So nothing fancy here. And then from there, basically what we'll be using is a few different things that the Tableland team has built. So we have Tableland, so the dependencies that we'll need here are the Tableland EVM package. So that's like where you can actually access and use all the Tableland smart contracts. We have another package for the SDK, and then we also have a hard hat specific plugin that makes it easier to like build locally with Tableland. And then I'll also be starting installing environment just to access some local variables. And then I'll basically kick off and do like most of this programming with something that we built called local Tableland, and it's like extremely helpful for local development. And what it does is actually, so when you think about Tableland, it's like this dual pronged network. You have like on-chain interactions and then the Tableland network that sits beside it. So it enables, like the whole network is based on event-driven development. So like the Tableland smart contract is called the register smart contract, sits on chain. So you technically, like, in order to develop locally, you have to have like a node running and actually have deployed the Tableland register smart contract. And then in order to develop locally, you also have to have like a Tableland node that is listening to that event in order to make like the SQL database accessible. So it'd be a lot of pain to like set that up yourself. So we just do it for you with the, install this. Yeah, so that's what the Tableland local package does. And then last thing we'll do here is just set up a .env file. Can't remember. Stop sharing my screen real quick for that components. But here you'll just set up a private key for a wallet. I think this one is safe to share, but I'm not going to go into it. Okay. Let's pull my window back up. Cool. So I'm going to start with the smart contract work, and we're going to change this up a bit and just import. Oh yeah, there's one dependency I also did not install, which is OpenZeppelin. And OpenZeppelin is extremely helpful.
Dan, can you zoom in just a little bit more on the text? Just make it a little bit bigger.
Yeah, is this a little better?
Yeah, that's good. Thanks.
Cool. Let me force this. Okay, cool. So now that we have our dependencies, I think that's just an error. Okay, cool. So we'll start and just like basically remove all this boilerplate. And we're going to rename this contract we'll call it FVM. And so we import a few different things from the Tableland EVM package. So we have our Tableland deployments, which is like a helper. Same with the SQL helpers, they're utility contracts to make it easier to develop. And then towards the end, we'll actually have like controllers for dictating how information is read and or information is written to Tableland. And then relative to these last two components, we have OpenZeppelin contracts for strings and ERC 721 holder. So strings, this is helpful if you're writing SQL in your smart contract. And this ERC 721 holder, there's different ways to implement this, but we're actually going to have our contract own a table. And a Tableland table is an ERC 721 token. So in order to have this contract own the token, you have to implement some specific methods for that. And then we'll also just sort of drop some of these things in here. So some of the like configuration related information. What we're going to want is a table ID, and this is actually returned via Tableland once the table is created. And then this can be just whatever you want, but it defines like a human readable, what we call prefix for a table. So when like you're trying to query a SQL table, it has a name. Part of that name is going to be this prefix. And then we'll go ahead and create a sort of the constructor. And this is where we start to introduce some of the Tableland concepts. So in this constructor, you'll see that we have this Tableland deployments get method called. And under the hood, Tableland deployments basically uses or infers the chain ID based on whatever network you're on. And with that information, it automatically directs you to the right network. So you don't really have to think about, like, if you're doing multi-chain smart contract development, because Tableland is on some other chains. This makes it easy, but under the hood, when you use Filecoin, Hyperspace, or mainnet, it would automatically just retrieve the Tableland smart contract deployment for the registry smart contract, and then allow you to actually create and mutate data. So this create method is saying, okay, go to the Tableland smart contract on Filecoin Hyperspace and create a table. And the first parameter here is the address in which you want to mint the table to. So this is saying, hey, I want to actually send this table to the smart contract. So the smart contract is going to own the table. And then this SQL helpers method makes it a little bit easier to actually formulate the statement itself. But really all that's needed here and what it's doing under the hood is like a standard SQL create table statement. So it's doing something like that. Create table, FVM table. And then we're defining our schema, and here, so we're saying that, okay, we have 2 rows or 2 columns, an ID, it's an integer, it's the primary key, and then we're going to have another column, it's a value, the identifier is val, and it's of type text. So what's cool is that when we actually deploy this contract, we're creating the table, we're minting it to the contract. So now the contract owns that table and it has like data that it can write to it. So the next step we're going to do is actually just even write data to this table within the constructor. And of course, like if you're developing, there are a lot of different ways you probably want to write your actual data. Here's just like a cool example of how you can do it within the smart contract. But as I noted, we'll also just like quickly show how to do that with the actual like Tableland SDK too. So with this similar pattern, Tableland deployments get, and now we're calling the mutate method. And mutate is telling us that, hey, we want to mutate data. We want to write data to this table. So who is making this call? It's this address. It's the contract that actually is writing the data. What is the table ID? Remember that up here we stored the table ID. It's one of the storage variables in the contract. And then we're going to call the SQL helpers to insert method, which makes it easier to insert data or just like write that SQL insert statement. So if you are new to SQL, it's like an insert into type of setup where you say, hey, I want to insert data into this table. Here are the columns that I want to insert data into, and here are the values that I should be inserting as well. So insert into this table, here are the columns, here's the table ID, table prefix. All this again like formulates the proper statement that Tableland needs. And then as far as the data, we're just going to keep it really simple. We're inserting a value of 1 for the ID and a value of Bobby tables for the value, the column of val. So really simple setup. But when we deploy this, the actual deployment process will spin this up and spit it out basically. And then lastly, we're just going to drop in a bunch of different helper functions that'll be useful when I deploy this shortly. And let's just leave that for now. So what I added was a basic function just to retrieve the table name, a function to set the controller. And a controller is the way that you dictate how writes happen for a specific table. So you can set the controller, you say, hey, here's the person making the call, here's the table ID, and then here's the controller contract address. And in this scenario, I actually am going to create the controller as the contract itself, but it could be a separate contract entirely. So then in order to do that, just spin all the way up here. We're going to say, so if we like just sort of reset again, contract FEM is Tableland controller in order to access those the policy methods that I'll be showing in a second. And that's all about the Tableland controller and data control, access control. And then as noted, that ERC 721 holder to make sure that this is possible such that the table can be minted to the contract. So we have our constructor, create the table, write data, some helpers to either get the name or that makes more sense now. Get the name of the table or set the controller. And then lastly, this get policy is really where the fun happens. So with the policy, what happens is the Tableland registry smart contract says like, hey, someone wants to mutate data. They try to mutate it. Tableland registry wants to make sure they have the right permission. So this get policy is where you can define exactly how you want mutability to work within your application. In this scenario, I'm keeping it really simple. I'm saying, okay, once I actually set this controller, anyone can insert, anyone can update, but nobody can delete, and they can only do this for this specific where clause. So only if the ID of the row they're trying to update is greater than 1. And they can add other things like checks or here I'm defining the updatable columns, which is just the value column. So it's cool where you could add a ton more before you actually return this policy or have like different control flows, or maybe it's checking ownership of an NFT. And if so, they have access to insert or update data, but only for these columns. Or maybe if they don't have any of that, you return a policy that says false for everything. So dynamic access control is all on chain. All right. And last thing, I'm going to change this to FVM real quick. So cool. That's our smart contract. It's really straightforward, but it'll get the job done here in a second when I set up the deploy script. So here I'm going to drop in and actually simplify this up a bit. So the deploy script is going to take that FVM smart contract. It's going to deploy it, and then it's going to we're going to take one of the values from this and add it to our hard hat config, which I'll set up here before I actually do that. And what's unique with like some of the tooling that I mentioned earlier is that we have this like local Tableland setup. So it makes it easy to spin up that Tableland network as well as that hard hat node in a single script. And then when you deploy to Filecoin hyperspace, we'll need to establish this network. And then lastly, this contract, since I'm developing locally, this address is going to be deterministic based on what I deploy here. But note that as you deploy a contract, this contract value will definitely change. So when I look at some of the other scripts that I'll show here, be sure to update the contract address. Cool. All right, so now let's deploy this out. So first, we're going to spin up the Tableland node in one terminal. And you'll see on the left-hand side, if I zoom, make this a little bit bigger. So first what happens is a hard hat node is spun up, and then after that, you have information that says validator, and that's like the Tableland validator node that it is now running. So this gives you access to write and read data. And now I'm going to deploy that contract. Cool. So as I said, make sure you save that contract address. And just to like test this out real quick, we can actually read the data. So we're going to create a file called read.js and drop in a bunch of code here. Okay, cool. And so what this is going to do is just simply get information about that table. And maybe like a different way we can even do this is with the Tableland just REST API. So if I pull that up real quick, let's see, I'm here. So if you recall in that create statement, we had, or that in that constructor, we had actually written data. We said the ID was 1, the value was Bobby tables. And the endpoint that we're hitting right now is a localhost 8080. I can drop it in the view here shortly, but we're making a query, a SQL read query. directly to a gateway that validator is hosting. So as you mutate data, this information will also be updated. So we go back to the scripts. This was actually what I was, the address I was accessing. So you can see it's just some endpoint being hosted locally, making a query statement, and then this is where I was just saying like select all from this table that we just deployed. So that was what was happening under the hood. And now we can then also even like write data. So if you want to write information, this is where it gets interesting because we can write data using just JavaScript. And if I try to do this initially, what's going to happen is this will actually fail, because if you recall the smart contract itself, like the default rules is only the owner has full permissions to do whatever they want. So that's like the default thing that happens when you create a table. So right now, the only thing that can write to this table is the smart contract. If I try to run this script, and I'll do it here just to show it as a demonstration, but with write, what I'm doing is importing a Tableland database, establishing that database, and then I'm calling that name method that I wrote in the smart contract just to get that table name. And then I'm using JavaScript to write data to the table. So I'm using JavaScript under the hood. It's making a smart contract call and making everything happen, basically. So if I try to do this, it's going to fail. And it's going to tell us that I don't have the right ACL permission. So this is good because this user that I set up with my private key, they don't have authorization. So now what I'm going to do is just create a set controller script. I'll drop that in. And what this is doing is setting the controller of that actual table. So in that smart contract, we had this set controller method where we said, hey, here's the table. We want to make the address for the controller of that contract that's also be the smart contract that we deployed. So then lastly, if we set the controller, write that script, or run that script, everything will be good to go. And now we'll see that if we try to write data, it'll successfully be written such that we're going to insert some random value called my value. The address being used is this F39 address, which, just to prove it, is different than the contract, which initially had the only correct write permissions. And then if we go back to the endpoint that I was showing there a second ago, this is what it initially was, and now we can see there's a value there. So dynamic access controls, collaboration, SQL on the front end, SQL on the on-chain, and there's so many things that you can do with this around just data ownership, collaborative data, data DAOs, application data. You know, really the limits are endless there. So I think I got a couple minutes left, so I wanted to pause there and make sure we had time for any questions or comments, etc.
Yeah, that's great, Dan. Thanks a lot. Okay. Let's just, I'm just checking here to see if we've got any questions in the chat. I'm not sure if we do here. Yeah, it just still blows my mind that, you know, representing SQL tables as NFTs and knowing this is all SQLite in the background, you know, just seeing within your JavaScript, the sort of usual prepare, you know, bind, kind of, you know, methods that you'd normally see when doing any kind of SQL stuff, you know, doing all that in this sort of Web3 senses. That's pretty cool. So, yeah.
Definitely, yeah. And if for anyone that is newer to Tableland, I just pulled up our website. We just revamped it a bit. So tableland.xyz or docs.tableland.xyz if you are trying to like get started, dive into things. I guess I did share a repo or create a repo. I can drop that in the chat in case, yeah, you want to follow along for anything that I did there.
Cool. Yeah, I'm just grabbing that link now and putting it into the chat for others there. Brilliant. Thanks a lot. And yeah, another thing to check out, people check out Tableland's rigs little NFT demo game type virtual world thing, whatever it is. It's really cool. That's a fun. I always like seeing that. Which is really cool. So yeah,
definitely.
brilliant. Okay, great. Well, fantastic. I think we're just up on time. So yeah, if people have any further questions, if you want to ask them in the Discord channel, so Carleen Papillion has just put the link in the chat there as well, and there's a Tableland sponsor channel in there as well in the Discord, IPFS Discord. So if you've got any further questions, then you can ask then. So brilliant, fantastic. Thanks very much, Dan. That was great, and yeah, let's see what people start building. And I'm really wanting to check it out too. I haven't had a chance to actually get my hands dirty with Tableland yet, but I'm really looking forward to playing with it myself because yeah, it looks really cool.
Awesome. Yeah, let me know if you run into any issues, questions, or anything. But yeah, thanks again for having me.
Yeah, no problem. Great. Okay then. So next up we have